Hello again. It's literally 5 seconds later from the last video, and I'm going to go ahead and get going with example 5, word problem. Everybody's favorite, I know. So it says a pilot sets out from an airport, and our airport's right here where it says capital A, and heads in the direction north 20 degrees east. So if you follow along with me, the plane is going up and to the right, because east is to the right, 20 degrees. So that right there is the direction that it's going right now, from A to B. All right, flying at 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction north 40 degrees east. So for 1 hour, the plane went a distance of 200 miles. He then gets to point B, and now he's continuing to go up and to the right, but he's changed his angle measurement to 40 degrees. All right, that's what that's telling us. So he started off going north and to the right 20. Now he's changing it, and he's going to go north and to the right 40 degrees. A half an hour after that, engine trouble forces him to make an emergency landing. Well, if he's still flying 200 miles per hour, then a half an hour later, he has gone a distance of 100 miles. So that's where that 100 miles is coming from B to C. And this is where he made his emergency landing. So we have a couple of questions that we're being asked to find. We want to find the distance from the airport and where he landed. So in other words, at the end of this problem, we're going to be able to say that AC is approximately something. That's what we want to find. And then part B says find the bearing from the airport to his final landing point. So when they ask you about the bearing, that means an answer that looks like that. So we know, we know originally he did north, east, 20 degrees. Then he made a correction and he did north, east, 40 degrees. But what this question says is, what would it have been if he had gone straight from A to C? What would that bearing have been? So we'll come back to that. Let's go ahead though and start with letter A. Now this is going to take some of your geometry memory. So if you can kind of envision that this little dotted line here kept going, you probably can realize that these dotted lines are parallel lines. Remember, in geometry, we learned a whole lot about parallel lines and what happens when they're cut by a transversal. Remember, they make all sorts of cool angles: alternate interior angles, alternate exterior angles, corresponding angles, and consecutive interior angles. So looking at the picture, this angle right here is 20, and it would be alternate interior from this angle right here. So I now know that that particular measurement, and this is going to be hard to write in here, is 20 degrees, because those are alternate interior angles. Let me see if I can make that a little bit bigger for you. Can y'all see that? So we have 20-degree angle right here, because those are alternate interior angles. Now also, if you go back and remember about some geometry problems, you can probably figure out that this line right here and this line right here, those are perpendicular lines, which means that they form right angles. So from here all the way to this other dotted line is a total of 90 degrees. Well, we've used 40 of them right there, so that means that this remaining part right here is going to be 50, because they have to add up to be 90 degrees. I'm sorry that this thing is shaking. Every time I move, it shakes. Okay, so guess what? Perpendicular lines means this right here is also a 90-degree angle. So 90 degrees. Now, why did we need to know all of that? Well, angle A, B, C, so B is the vertex, is all of that together. That 20 degrees, that 90 degrees, and that 50 degrees. And so that means that angle B, can y'all see that? Is 160 degrees total. I'm not doing a good job sorry y'all, is 160. Everybody good? Because I'm about to bring it back in. Okay, so everything's moving, stop moving. Okay, all right, so here's the question for part A. Part A says find the distance, which we talked about was gonna be AC. Guess what? That's little b, because that's across from capital B. So that tells me I'm gonna use the formula b squared equals a squared plus c squared minus 2 times a times c times cosine of angle B, because we have everything except little b. So little a, anybody have an idea what little a is? Remember, it's across from angle A. That's that 100-mile side. Little c, across from angle C, that's that 200-mile side. So I'm plugging those numbers in for A and C, and now I'm going to also plug in the 160 degrees for angle B. So now I'm going to use my calculator. So 100 squared plus 200 squared minus 2 times 100 times 200 times cosine of 160 degrees. Now remember that that answer that we got isn't b, but it's b squared. So I'm going to square root it. So I'm going to square root my answer. And I'm going to find out that it's approximately 295.95. So b approximately 295.95. So let's just answer it and say that AC is approximately 296 miles. All right, how's everybody feeling about A? I'm envisioning that everybody's face has a smile on it and you are having just as much fun as I am. So all of that was work for part A. Now let's talk about part B. So remember, part B is asking us to find the bearing, which means from A to C, obviously we know it's going to the north, and we know that it's going to the right. What we need to figure out is what is this measurement right here. Can you see that? I'm gonna attempt to zoom in and, can you see it? Can you see it? So what we wanna find out is what this angle measure is. All right, now here's the thing. We already know this is 20. What we need to then find out is what's the measurement of this angle. Going back out, maybe. Here we go, y'all. So what we need to find, let me move this around. Why is everything so weird? Hold on. There, no, just kidding. This is so much harder than I thought. Okay, so we need to find angle A. So I'm just writing myself a note. Find angle A. All right, well, angle A is clearly a very small angle. It is acute, and so that tells me that I would be perfectly fine with using the law of sines. So I've got sine of angle B, which was 160 degrees, over little b, which we just found out was 295.95. I'm going to use that. It's a little bit more exact than the 296. I'm going to set that equal to sine of angle A. That's what we're trying to find. And we're going to put it over little a, which was 100. And so I'm kind of running out of room. I feel like everybody could probably figure this out. We're going to cross multiply. So we're going to have 100 times sine of 160. And then we're going to have to divide by 295.95. And that's going to get sine A by itself. But we don't want sine A, we just want A. So we're going to have to inverse sine. So why don't you put this on pause and try that out for a minute. I'm going to be punching my numbers into the calculator. And hopefully everybody's got something. I'm finding out that angle A is approximately 6.6 degrees. All right, not too hard, but not the final answer. Remember I told you guys earlier that when they want the bearing, that means that your answer needs to look like this. Well, the good news is we already know the direction. Obviously the plane was going up, that's north, and to the right, that's east. So remember we said we needed this angle measurement right here. We now found out this sliver is 6.6, but we needed to add it to the 20 that was already there. And so that middle angle right there is 26.6. So we have north 26.6 degrees east. How are we doing? I'm imagining thumbs up signs. See, I'm so glad to know that. All right, guys, we're almost done with these notes. So another formula, because you just needed and wanted another formula, I could feel it. I love this formula. This is the formula for the area of a triangle. So you've learned area of triangle formulas, several. We learned one, maybe it was earlier in the chapter, the 1/2 AB times sine of theta. Do y'all remember that one? We learned, obviously you remember the one from pre-algebra and algebra and geometry, 1/2 times base times height. That one only works if you have a right angle. The one I mentioned before only works if you have two sides and the included angle. But what happens if you don't have any angle measurements at all and you don't have a right triangle, but you do have information about all three sides? Well, that's where this formula called Heron's formula comes in. So A, B, and C represent your three sides. That's pretty easy. S is called the semi-perimeter. Basically what's happening is you're taking half of the perimeter. Now remember, perimeter just means the area around the triangle. That just means you're adding your sides up. Semi-perimeter is when you're chopping that in half. So you add up the sides, chop it in half. That's what S is going to represent. So you guys ready to use our formula? These are really pretty easy. All right, so this says, a businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the three adjacent streets are 125, 280, and 315 feet. And we are being asked to find the area of the lot. So the first thing I'm going to do is find the semi-perimeter. And that means that I'm going to take 1/2 of the perimeter. So I'm going to be adding the 125, the 280, and the 315. And I'm going to take half of that. And yes, I am going to use my calculator because I'm getting kind of tired. I think it might be close to 10 o'clock at this point. And at some point, I really want to go to bed. So I've just done all of that, and I've got the number 360. Are you guys getting the same number? Okay, well, here comes the really hard part. I hope y'all are ready. Plugging it into the formula. So we're going to have S times S minus A times S minus B times S, I was about to actually write S, minus C. That was really hard, wasn't it? And now we're gonna plug her into the calculator. And I like to plug it in just like I see it. So everywhere I see parentheses, I'm putting those parentheses. Can y'all hear the tired in my voice? All right, so I'm plugging it in. The cool thing about this formula is once you plug it in, it is what it is. So I have plugged it in. That is what I have come up with. Pretty large number, huh? So we're gonna say the area is approximately 17,451.6. We need some units, right? Feet, and area is always squared. All right, guys, well, good news. That not only concludes section 6.6, but that includes chapter 6. Whoop, whoop. So I will be talking with y'all about quizzes, tests, all that fun stuff. And I guess that's it. Bye.